Welcome!
This video develops voltage from electrostatic first principles. Comparing electrostatics to gravitation provides intuitive insight.
Voltage is the difference in electrical potential between two different locations. Electrical potential is the electrical potential energy per unit charge. To understand potential energy, both electric and mechanical, look at forces like Coulombs' law. Forces are related to field strengths. Capital E is electric field strength. Gravitational force and potential are good analogies for the discussion of electrical force and potential. Field strength makes a good starting point for the discussion of potential, working up from the field strength through forces and potential energy.
Isolated electrical charge has an electric field radiating from it. The positive value of electric field strength E and the arrows pointing outward correspond to force that repels other positive charge. Mass has a gravitational field. The negative value of gravitational field strength G and the arrows pointing inward correspond to force that attracts other mass. Capital E is the electric field strength measured at a distance r away from the charge minus Q. The negative charge on Q corresponds to field strength arrows pointing into minus Q and force that attracts positive charge. Small g is the gravitational field strength measured at a distance r away from the mass capital M. Small g has units of acceleration. The negative value of the gravitational field strength G corresponds to masses attracting each other. Coulombs' law says that the force between charges capital Q and small q varies by the inverse of the square of the distance r between the two charges. Similarly, the gravitational force between masses capital M and small m varies by the inverse of the square of the distance r between the two masses.
Generally, force is a vector quantity. In these examples, the radius r is a one-dimensional straight line, and the vector notation is not always used. This slide shows two different vector notations. In the electrostatic force equation on the left, the vector quantities are in bold. In the gravitational force equation on the right, the force vector is indicated by an arrow above the F. In both cases, the r hat notation is a directional unit vector.
As the distance r between charges capital Q and small q increases, the force F sub E in Coulombs' law decreases. F sub E decreases in proportion to 1 over the square of the distance r. As the distance r increases, the gravitational force F sub G becomes less negative. That is, the vector magnitude, or absolute value, of the gravitational force F sub G decreases. F sub G increases towards 0 as r increases. Let's connect the field strength and force equations. Electrostatic force and gravitational force are quantified in terms of the electrostatic or gravitational field acting upon another charge or mass, respectively. The charge capital Q is the source of the electric field E. The mass capital M is the source of the gravitational field G. The charge small q is being acted upon by the field from the charge capital Q. The mass small m is being acted upon by the gravitational force from mass capital M. The subscripts in the field strength equations capital Q, capital M, and small m refer to the charge or mass from which the field emanates. E sub capital Q is the field strength emanating from charge capital Q. G sub capital M is a gravitational field emanating from mass capital M. The subscripts in the force equations refer to the charge or mass being acted upon by the field emanating from the other charge or mass. The forces work in both directions. The electrostatic forces F sub E small q and F sub E capital Q are equal to one another, and the gravitational forces are also equal to one another. From force, we can calculate potential energy, namely the change in potential energy from moving through a given force field from point A to point B. The integral of the vector force F is the amount of work W done by the force. Work has the same units as potential energy. Delta U sub E is the electric potential energy difference between points A and B. The integral of the vector electric field E from point A to point B. Delta U sub G is the gravitational potential energy difference between points A and B, the integral of the vector gravitational force G from point A to point B. When the force is linear and uniform, the force term becomes a constant that can be moved outside of the integral sign. The result is a simple expression that can be intuitive.
In the case of gravity, mgh is the common formula for calculating the potential energy of objects lifted up from the surface of the Earth.
These equations for electrical and gravitational potential energy have a reference point of 0 taken at an infinite distance away from the charge or the mass. In the electrical potential energy U sub E, positively valued work is required to bring a positive charge from an infinite distance away towards the other positive charge, because they repel one another. With gravitational potential energy, negative work is done to bring a mass from infinity towards another mass because they attract one another. Conversely, it takes positive work against gravity to separate masses further away from one another. The electric potential is the electrical potential energy per unit charge. The electric potential is a commonly used quantity. Gravitational potential is the gravitational potential energy per unit mass. Gravitational potential is not a commonly used quantity. The electrical potential leads us directly to voltage. Voltage is electrical potential difference. The units of voltage are energy per charge. 1 volt equals 1 joule per coulomb. Speaking in terms of lumped element circuits, voltage is the difference in electric potential between 2 points in a circuit. The concept of electromotive force, or EMF, is useful for understanding how electric potential relates to circuits. Chemical processes, like one finds in a battery, or induction like one finds in generators, are forms of EMF that cause voltage.
The study of voltage in this video provides learning foundation for the circuit theory in this book, first and second order circuits and equations, technical background and insights, available from Wiley IEEE Press.
From electrical field strength, one can calculate the force in Coulomb's law. Moving the charge Q from point A to point B in the electric field changes the potential energy of the charge. The change in electrical potential energy, delta U sub E, divided by charge Q, is the electric potential. Voltage is the difference in electrical potential between two different points A and B. Thank you for watching and learning with us.